part 3, let's take a look at what else it says in the grade 9 math curriculum that this unit needs to cover. I think we've covered most of it. It's really about powers. It's about knowing what a power is, knowing what an exponent is, knowing those 6 power laws. You guys have so far seemed to grasp all that. There's a little bit left, and today we'll just cover that end part. And I know for some of you this is a bit of a review, but we're going to look at something today called the order of operations. Okay? So here's what it says in the actual math curriculum. I'm not going to read the whole thing to you because it's a lot of sort of teachery talk, but it says focus on, make sure that students know the order of operations, now including exponents in that. Some of you may have learned this by previous math teachers, and you're going to see it today, the idea of BEDMAS, okay? But in BEDMAS, you may not have known what the E stood for, but now you will, okay? Okay, so let's take a look, okay? In my opinion, to get math, to really grasp what's going on in a math class, to really do well on a math test, 2 things need to happen. You need to know what the heck the question is talking about. So you need to speak the language. Otherwise, it's like walking into a room where you don't understand Japanese and they're speaking Japanese. You just don't understand. So know the words, what they mean. Math teachers like to sometimes make the words fancy to sound. All the time we're changing the words. Equivalent. Doesn't that mean the equal? Yes, it does. Why do you use equivalent then? Well, I don't know. It just is. Okay? But the second one I think is even more important. We talked about this last time. A method, a procedure, an instruction, a process, a technique. Basically a way to get from A to B. A is the math problem. B is the math answer. You need a way to do this. You need a way to get from the problem to the answer. And that's my job, is to teach you those methods. To make those methods available to you so you have them. Okay? So today let's look at one of the most common math methods known as the order of operations. Okay? It is a method, or a procedure, instruction, whatever, that basically decides what things you do first when you're doing math. Okay? What things do you do first to get the right answer? Now it's important, because if you don't follow it, you might get the wrong answer. So here's an example. Same problem. 2 plus 5 times 4. Same problem. I'm going to do it 2 different ways. Up here, as you can see, I'm going to do the addition first. I'm going to take 5 plus 2 and get 7. But on the bottom one, I'm going to do the multiplication first. I'm going to do 5 times 4, and I'm going to get 20. And then I'll do what's left over. And what I get is 2 different answers. One's right, one's wrong. What the order of operations says is let's all agree on a set of rules that puts these things in order so that we can't have this. We can't have both be right. One person has to be right and one person has to be wrong, so let's all agree on the rules. So the rules will make sure that you don't get this error. You don't accidentally get it wrong. The order in which you do your math operations matters. Okay. So now that we understand that we have to have these rules, otherwise it's just anarchy, there's no way I could possibly ever mark you wrong on a math test. It's like 2 plus 2 equals 1 billion. Why? Because. No. There's rules. We have to all agree to them, otherwise we can't do math. So let's take a look at what it is. Here is the order of operations. Okay? 1, always do brackets first. Brackets could also be called parentheses. You could also call them braces, okay, and not the ones that go in your mouth. They could be drawn more commonly like this, but also like that, or even like that. Less common, but absolutely, sometimes you're going to see those different styles of brackets. That's going to be the most common. Second thing is exponents. Now you know what exponents are. That's that thing where you raise it to a power. That should always be done next. Then multiplication and division. And those can kind of be done at the same time, but I'll talk more about that in a minute. And then addition and subtraction, and those can be done at the same time. But again, I'll talk more about that in a minute. But for those of you who haven't seen it before, the way to remember this is all based in one word. BEDMAS, okay? Or BEDMAS, you could even say. That's maybe an easier way to remember it. BEDMAS, okay? Those letters represent that order. That you do brackets, exponents, division, multiplication, addition, subtraction. Okay? Now, we're going to do some examples here. But the last four letters kind of are in a group, two groups. So we'll talk about that in a second. But let's go back to the first letter, brackets, okay? What brackets do is they create like a package. They say, here's a package of math stuff. And it's super, super important, so do that first, right? Make sure, like at Christmas morning, this is the package you have to open first because it's like the best one. So the brackets give you a signal that that's where you should start. You should start with the brackets. So here's an example, okay? So in this case, I would do what's in the brackets first, giving you my answer and then solving the rest from there, okay? Now, it might be the case that you have two brackets, like this one. In this case, it doesn't matter which set of brackets you do first. I can do this one first. It doesn't matter as long as I am doing the brackets first. So I'll do what's in here, I'll do what's in this package, and then I can finish the math problem. So far, it looks pretty simple. I could just have one bracket, or maybe I could have two brackets. Doesn't matter. But I could also get that. Okay? Now, this is a nasty problem, but in this one, I got tons of different brackets. And what I have is sometimes I have brackets inside of other brackets. That's called nesting. Like a baby bird is put in its nest, we're placing a bracket inside of a bracket. The way you do with that is you work your way from the middle out. So you can see here, you just go down to this little bracket in there. And I can solve that little guy in there. And then from there I can solve the bracket that it's outside of. And then from there I can keep going. Now I wouldn't give you one that's complicated, but you can see here that I could slowly solve the round brackets. Then I could slowly solve the square brackets. And then I could solve the curly brackets and then end up solving the problem. Okay? Now, I wouldn't give you one that nasty looking, but it's just showing you that brackets are just that. They're just a way to get started and a place to kind of grab where you are. More commonly, you're going to see a question like this one. This one you could get. Okay? Now with this one, I didn't draw different styles of brackets. It's all just those roundies. Okay? But with this, you can see I'm going to solve that part of the brackets first, then the inner bracket here, and then those two things together. That's the kind of question you can expect. Not necessarily like that one. That's just nasty. Okay? All right. Next comes exponents. Once you've done your brackets, now go to your exponents, which is what we've been studying this unit. Okay? So now you can see in a problem like this, I got to do that exponent first before I do the multiplication. Okay? Now, what happens if you have an exponent inside of brackets?
Then they take priority over other things inside of the bracket itself.
Well, but wait a minute. Brackets is the higher priority.
Yes, but consider the exponent.
Shh, just a sec. So you're kind of right. I still do what's inside the brackets. And now I start and think, well, what do I have to do inside the brackets? Well, the first thing I have to do inside the brackets is the exponent. And then I continue from there. So I would do the exponent. Then I would still work on what's inside the brackets before I finish that question. Okay? Order of operations. Watch out for tricks like that one. Make sure that you're kind of used to that type of question. Now, the last four letters, DMAS of BEDMAS, stand for division, multiplication, addition, and subtraction. But there's a little catch here. Division and multiplication are considered to be of the same order or of the same precedence, which means it kind of doesn't matter if you do division first or multiplication first. Doesn't matter. Same with addition and subtraction. One is not really above the other, as long as you understand that division and multiplication has to be done before addition and subtraction. But as far as division and multiplication itself, doesn't matter. Okay? Except for a few little exceptions. Okay? And here's one. Here's the same problem. Now in this problem I have both division and multiplication. So which should I do first? Should I do the division first or the multiplication first? Well, let me do it both ways. In the first way, I'm going to do the division first. 40 divided by 4 is 10. And in this one, I'm going to do the multiplication first. 4 times 5, and I'm going to get 20. And then I'm going to perform the second operation. 10 times 5 and get 50, and 40 divided by 20 and get 2. Those are two different answers again, and only this one is correct and this one's wrong. Because the way it works now is if you have both division and multiplication happening at the same time, you always work from the left to the right. So I went from the left and did this, and then did that secondly, moving from left to right. This would also be the same if I had both addition and subtraction. So for example, what's 4 plus 5 minus 2? Well, I go 4 plus 5, and then I subtract 2. So always go left to right. Now, the fact is, here in North America, you're already trained that way. We're trained to read from left to right. So that shouldn't be that hard for you. In other countries, might be different. But here in North America, we read left to right. So it's not a problem. Actually, Japan reads down. Okay. Since you asked me last week, I threw this in. Notice the background slide? Bonus. So for those of you who find exponents confusing, feel free to take a little nap right now, because good news, this is not on the unit test. Negative exponents is not. For those of you, however, who are at least considering doing pre-cal or applied math next year, let me show you what negative exponents are. Okay? A negative exponent means, okay, that we need to evaluate kind of what it does. So, for example, if I take negative x to the, or say, pardon me, x to the power of negative 2, and I multiply it by 1, it should stay the same, right? Anything times 1. But 1 would be the same as multiplying it by x over 2 over that, like that's 1 as well, right? If I take x over, that's also 1. And if I do that, and I actually started doing the fractional math on it, I could put this thing over 1 and do a multiplication there, okay? And again, looking at my exponent laws, I could keep going, and I could keep reducing this, and in the end, I'd get this weird answer. Now, I'm not going to go through all the specifics of it, but trust me, my math is correct here. I can turn this into this using a mathematical proof like I just showed you, which kind of shows you the 7th law of exponents, the law that's not on your unit test. By the way, that's good news for you because it used to be in the old curriculum, is anything with a negative exponent becomes 1 over that thing to its positive equivalent. Let me show you an example. Okay? Well, I'll get to an example in a minute. Now, this also is another way to prove this. Okay? Here's 10 to the power of 3, right? 10 times 10 times 10, which is 1,000. Okay? And 10 squared is that, 10 times 10. And 10 to the power of 1 is 10. And 10 to the power of 0 is 1. Now, 10 to the power of negative 1 is 1 over 10, or 1 over 10 to the power of 1. What would be 10 to the power of negative 2? Well, it would be 1 over 100, or 1 over 10 squared. And what would 10 to the power of negative 3? Would be 1 over 10 to the power of 3, or 1 over 1,000. It's confusing. Good news, this is bonus material. You don't need to know this stuff. But some of you are dying to know. And I said, well, let me tell you about negative exponents. They're a little trickier than you'd think. Okay? Now, let's see how you could do with that. Well, how could you solve that? Well, again, you could take 3 to the negative 2, put it as 1 over 3 squared, and you could get 1 over 9. So essentially, negative exponents are going to create fractional values. Okay? Here's some more examples real quick. Okay? What about that one? Well, it's the same as that, which is the same as that. Okay? What about that one? Oh, now it's weird because it's already in a fraction. Well, how would I do this one? Well, this one turns into this because I'm moving the 2 down here, leaving a 1 up there. Now I'm going to multiply those two things together and I'm going to get that. Okay? So this can get complicated. Okay? Same with this one. Becomes that. Weird. Okay? Which is that. Now, I'm just going to sort of zip through this because I'm watching the time, but I have actually a word problem in here that relates to science and radioactive decay that shows how a radioactive decay molecule can be used with negative exponents to calculate the decay rate. Again, because of our time, I'm going to kind of zip through this real quick, but this will be in your notes as bonus content for those of you who really want to strive forward on this stuff. I actually put a chart in there to kind of explain it. And what it's actually calculating is the number of years that it would take for that thing to decay. This would be a thing if you actually worked in like the field of radiation. It would be an important thing to know. Okay. So you can do this with variables like you're seeing here. X to the power of -3 when x is -2 could be solved by punching it in there and coming up with an answer. Okay? Again, watching the time. But this again stresses the importance of using brackets when using variables. It'll help avoid the mistake of getting it wrong. Okay? Here's another example, a little more complicated, and another example. Okay? Okay. I'm just going to skip through these last few examples because I'm watching the time and we're running out of time today. And you could then now define it as a law, the law of negative exponents. Okay? Again, just a couple quick examples. Okay? Same thing with the negative exponents. I don't think this is something you need to worry about, so I'm going to zip ahead. Okay? We'll wrap up by just taking a look. The reality is, the key concept of this unit is, or this presentation is, use BEDMOS to your advantage, do not make mistakes. Brackets, exponents, division, multiplication, addition, and subtraction. Make sure you understand it, make sure you use it. It's a way to keep things in order. It's part of your curriculum, and it's part of this unit. And it is the final part of this unit. All right. To wrap up today,